Find the solution of the following problems using the method of undetermined coefficient. For your information, it's the method of undetermined coefficients that is what we have just found out. And now, this is method of undetermined coefficient for a first order differential equation. I'm making this specific because when we get to second order differential equation, we have another method called undetermined coefficient. But that one is for second order. And even we have a higher order. And that one is for second order, but this method of undetermined coefficient is for first order linear differential equation. So please don't forget that. So is that of the first order linear differential equation. That is when you are going to find y of h, which is the homogeneous part of the equation, and y of b, which is that of the particular solution. And when you want to get the general solution, then you add the y of h to the y of b. Please don't underestimate this method. There are some questions or there are some exams that you will be asked to strictly go by this method. In fact, we will be doing the method 2, and when we do that, you establish that that method, which is the method 2, is quite easy. But don't stick to only that, because there are some times that you will be restricted to find this. Let's say that before you come to the general solution. That means that with that second method, you cannot get this and you can't get this. You only get this to be correct, but since you are not getting this and this, that will be wrong. Alright, that will be wrong. So make sure you grab the two concepts well, and it's going to help you throughout this course. Alright, so you'll be looking at this. Make sure you write it. I'm going to play it and come again for us to solve them. Now, the interesting thing is that I'm not going to solve all. But we have 6 questions, right? I may solve at least 3 of them. So that you will go and exercise the rest on your own. Thank you. Alright. One important thing in learning mathematics is memorization. Alright. I hope you can memorize all the steps that you go through in deriving the formula for the general solution. Please, as I said, it's the same thing that we are going to do here. So, in case you have forgotten it, make sure you go back and refresh your mind. So, what is the first thing to do? The first thing to do is that you have to make sure that it's in that form. And that, which form is that? That is the form of the non-homogeneous. You have to make sure that it's in the form of a non-homogeneous. So the y prime is the same as the y dx minus 2y is equal to 2x to the power 4. So for us to make it a non-homogeneous, we multiply 3 by 1 over s. I think we have done this already, similar to this. Okay. One over s times 2y is equal to 1 over s times 2s to the power 4. And with this, we are going to get dy dx minus 2 over x times y is equal to 2x to the power 3. You can see that we are in the non-homogeneous form. So now here, how do you bring the homogeneous part? We can bring the homogeneous part by equating this to be equal to z, and that is the homogeneous part. Alright. Then after this, what do? You solve the solution for the homogeneous part. And how do we do that? By making it separable. So you send this to this side. So for us to make it separable, I hope you are watching. Make sure you watch it. Then we integrate both sides. I want to bring every step. Factor these two out. This gives ln x, ln y. And don't forget that we will make y the subject. Ln x plus c. And this ln c, we can write it ln c. So that we can combine this. We can write it as ln s squared. And here, since it's square, you don't bring down both sides. This is multiplication. So cs squared. Then we take the natural log of both sides. So we take the natural log of both sides. We are going to get y is equal to. See, I'm taking my time to take you through, right? You can see that the proving is difficult. Oh, I'm lost. What's all these things? But even if you are not able to grab the whole concept in the proof, it still enlightens you some more about solving the question. Alright? So it's good to do that. You may not be asked to prove that formula, but it's giving you a sense of idea in solving the question. So when we had our first equation, we said that then we have to write subscript h to represent the solution for the homogeneous part, and that is cs squared. Let's say this is equation 1. Then we are saying that if this is representing the solution for the homogeneous part, we need to go for the particular solution. So we write this as y of p. The h change to p, but here it will be the constant c will be in terms of x. Then we multiply by the s squared. Now, having this, the problem is that we need to go for c of s. We need to go for c of s. And why are we doing that? The reason is that we want to go and find c of s. So we come back to okay. So we have established the first one. Then we go for this. And how do we do that? I would like to clean everything. I would like to clean everything. But since we will be in need of this, let me write that here. Alright, make sure it cooperates well. Then you come and pick y of b is equal to. Then you differentiate this. So how do we differentiate this? We get dy dx to be equal to. You can choose to make it dy subscript p, alright, but it doesn't matter. So to be equal to, this is a product rule. So differentiate this, leave this, plus leave this, and differentiate this, which is 2x. I hope that is clear. So now we have dy dx. And this is representing the function y. So we go and do the substitution. I hope you remember. We go and do the substitution to the first order linear differential equation that we have there. And that is going to give, so dy dx is the whole of this. And the reason why we are doing all this is to find the c in terms of x. Alright. It's for us to find the c in terms of x. So, wherever you see the dy dx, you replace the whole of this there. And that is okay. So minus 2 over x, and that is multiplying the y. And we know the y to be this. Don't forget, the y is not this, but rather this. So, we have this to be this minus this multiplying this. Then we equate it to 2. Okay. Let's continue to simplify it. So c prime of s, here, no matter what you like, something must kill a man. Something will cancel something. So let me write this one. 2s minus this and this, we get 2c of x over x. But don't forget, this will cancel one of this. So we get here to be x, which is equal to 2x equal 3. And now, as I said, something must kill a man. We can write this as, because I can see something here, we can write this as 2x, and this will cancel this. So we get c prime of x multiplying s squared is equal to 2x to the power 3. So we have this to equate to this. Alright. Now we are making, don't forget, we are looking for c of x. So we make c prime the subject. So we get 2x raised to the power 3 over the s squared. So C prime of S is equal to 2x. So in order for us to go, I hope it's not difficult. Just grab the steps, alright? So sometimes you need to memorize the steps. From here you go here, from here you go here. Like that, that's how we do mathematics. So we need to integrate both sides as respect to S for us to get C of S to be equal to 2. So here we get 2. Please don't add any plus C. Don't add any plus C. So here we get 2. Alright. Alright. So that is that. And now that we have, I can clean this one. So just by taking the derivative of this product rule, then come and do substitution to this and get that. Now that we have this, then that means that therefore, or this implies that y of p is equal to 2x squared. So 2x squared is the particular solution, and y of h, which is c x squared, is the homogeneous solution. Is a homogeneous part solution. So now that you are done with this, that is not all for that. To get the general solution for the first order linear differential equation question, that is going to be y in terms of x of y of h plus y of p. Therefore, we get y of h is plus y of p. Then this becomes the general solution for our first order differential equation. Oh, wow. I hope it's not difficult and I trust you understand it. Alright. We will be looking at our next question to do. Alright, so we go through this question. Here, I have picked the question 5. As I said, after this, one more left. So for you to go and do the rest. Alright, so we go through the same procedure, the same concepts in getting the general solution. Very good. So what do we do? Let's leave it in the proper form. dy dx. So we divide through by you are going to get 1 over 1 plus x multiplying this y, okay? And here, don't forget we divide by 1 plus x. Very good. So having this, that means that we are in the proper form because this is the p of s, this is the q of s. Alright. So we write the homogeneous part. So we write the homogeneous part to be so this is the non-homogeneous and this is the homogeneous. Alright. Now the next thing to do is to send this to this side. So for us to make it separable, we know what we will do. Then we integrate both sides. We get ln 1 here. But with this, that is going to be negative ln s plus 1. I would like to write it that way. Plus ln c. Plus ln c. Now, we have this. Hope you are following. This negative will raise to this to get that. You know that from your algebra. So we can combine what we have there. Then we take the natural log on both sides. Hope you are not lost. This is the same as this. Therefore, this gives the homogeneous part. Just take your time, go through the process. So this is the homogeneous part. Most of you don't like this method, but it's good because, as I said, question can restrict you to use the method of undetermined coefficient. And if this gives the homogeneous part, so this is the homogeneous general equation. Then what will be what will be for the non-homogeneous? So that is you going for the C of S. So we use the homogeneous to get the non-homogeneous. So and that is the particular solution. So we just write this in terms of X. Then we go through the process. Alright. So you can name this equation 1 or whatever, but doesn't matter. Very good. Let's quickly go through. Oh, I will be in need of this part. No, this part rather. We will be in need of this part. It's good for us, it's good for you to know where you will be in need of. That tells you that shows that you know what you're doing and where you are going. So now with this, our problem here is for us to find C of S. And the problem here that we have to find the C of X. We have this Y, you know that after everything, after getting the divide dx, we go and do the substitution to this part, alright? We will need the Y is here already. But what about the divide dx? So we need to go and find that. Now, don't forget, the numerator is a function, the denominator is also a function. So what method in differentiation will help you to do that? Quotient rule, very good. So let's apply our ideal quotient rule here. So divide dx is going to be low the high, that will differentiate the top, the high, minus high the low. And when you are differentiating this, don't forget that this will go 0. The s will be 1. And when we are multiplying this, the same as this. you square the battle. Alright, so that is s plus 1 all squared. So this is what we have for the dy dx. And we can simplify it, okay? I would like us to leave it in the form. You know that we can get c prime of s over s plus 1. I hope you know that because 1 is here and you cancel one of this, so that is that. Minus c of x over s plus 1 all squared. It can never be difficult if only you know what you're doing. I know how most students struggle to understand this method. That's why I'm putting my thing. So now we do substitution to this. Don't forget, it's not the other one. It's not the question. It's not the question. That question is not in the form of a first order linear differential equation. It's not in that form. So don't go for that. Do the substitution to the non-homogeneous part. So by this, dy dx is this. So that is dy dx plus 1 over x multiplying y. And the y that we know here is this. I don't want to play this. So let me play this. Okay. Oh, I'm lost. Okay, 1 over, okay. Multiply the y equal to cos s over s plus 1. I would like to write it s plus 1, okay? So, as I said, when you get to here, whether you would like it or not, something must cancel something. If it does, make sure that you are on the wrong path. So with this, okay, this multiply this, so you get this. Hope you can see that. Very good. C prime of s plus 1 plus, equal to cos s over s plus 1. And now with this, we can multiply through by s plus 1. And when you multiply through by s plus 1, you know that you're going to get c prime of s is equal to cos x. Please, those of you at UEW, this information is going to you. In fact, if you have my PDF format of the first things I saw, in fact, about 200 pages I saw within a short time or within some days. Please, there are some of them that you identify a mistake in. In case you identify the mistake and you are still not getting it, come to the video, okay? And with the video, I have done the correct thing there. In fact, I think this particular person, I made a mistake. I don't all that know, but I think something like that. But this is the confirmed one. Alright, so in case something is bothering your mind or what you have done there, just focus on the video, and in case of anything, you know my email account, you can book me a message. Alright, so let's move on. So we integrate, so for us to get C of S, to do the substitution to here, we integrate this as respect to S, and this gives C of S is equal to this. When you integrate cos, you get sin S, you get sin S. Please don't add plus C, you get sin S. So now that you have C of S, you just come back. You just come back to write the y of p, and you know that the C of S, so you are coming back to do the substitution, don't forget. So the C of S is sin x over s plus 1. But don't forget that the y of h, that is the solution for the homogeneous part, is c over s plus 1. But I have forgotten to let you know this. Why do we call this a particular solution and this a solution for the homogeneous equation? You can see that this is a particular solution because it's not in terms of any C, but this is in terms of C. So this is a general solution from the homogeneous part, and that's for the particular solution. So for us to get, I hope you are enjoying it. Trust that. So for us to get a general solution, that is y of h plus y of p, and that is going to give you y of h c over y of p, that is so in all we can get, thank you for that. So this is the end of the question 5. Please don't add any plus C. It's in terms of C already. So this is the general solution for the non-homogeneous equation. Or you can say that for the first order differential equation with the method of undetermined coefficients. Alright. Which question should I pick again? Let me look through and see the question to pick. Alright, I'm sure somebody is saying that. Please try the C for the 3 for us. The question 3. The question 4. Okay, let's do the question 3. Alright. The only thing that you need is to know the steps. And if you are good in differentiation, then that means that, or if you are good in calculus 1 and 2, there is nothing that is going to be difficult here. I'm going to take my time again to explain it to you. Now, looking at this question, you can see that it's not in that form. How do you know the form I'm talking of? It's not in the form of a homogeneous equation or a first order linear differential equation. So let's go and leave it in that form. Alright. In fact, I forgot to introduce this to you, that you know that a first order linear differential equation is in the form dy ds is equal to plus p of s multiplying y is equal to p of x. Alright. Now, this is like you having a linear equation, y is equal to ax plus c. Okay. So, you can see that here, the x here is 7 and the y here. It's something in that form, right? In fact, when we get to the second method, you will get to know what I'm talking about. Well. But this just by the way, let's go to this to leave it in a better form. So, if you have y prime, you say dy dx. So if you have x prime, know that this will be dx dy s times t plus sin t. Oh! So this means that there will be no y because the function is in terms of t. So this is supposed to be dx dt. But please watch. But not dx dy. Alright. So that means that the s is representing the function here. The s is representing the function here. Alright. So let's turn to this side minus tan t. Then the function s will come. Then we equate it to sine t. I hope you can see that here we are in the form of a non-homogeneous. Therefore, we can break the homogeneous part out. Oh, wow, very good. So that is the homogeneous part. And you can solve it with the idea of a separable differential equation. And with this, we can make it separable. Divide by x. When you are done, cross multiply this. Then we integrate both sides. This is ln x. When you integrate tan t, what are you going to get? In case you can't remember. When you integrate, we know that when you differentiate tan, you get x squared x. But when you integrate x squared x, you get tan x. But the integral of tan is there, and that is ln sec x plus tan x. In case you have forgotten, plus ln c. That is plus c, then you make it ln c. So that is that for that. Alright. Integral of tan is going to give us ln sec, since in terms of t is sec t. Okay, plus ln c. Very good. So now in case you are confused of integral of tan t, you can go for this sine over cos. Alright. Take u to be cos. Can we do the substitution? You are going to get this in case you have forgotten. Alright. So this gives c will multiply sec t. Then we take the natural log of both sides. And that is going to give us S is equal to C sec T. Now, this becomes the general solution for the homogeneous part. And that is that. So for us to get for the particular solution, we make here C of S. You know the steps already. So then we go and find C of S. Oh, we'll be in need of. Oh, I have cleaned that part. Shit. We will be in need of, I think this. Okay. But we need to send this to this side. Okay. Alright, so let's move on. So we have S of P is equal to so we need to go and find S ds over dt. So this becomes a product rule. Differentiate this, leave this, plus. If for differentiation is good, I don't know why you should be worrying about this. Alright, so C prime of that, then we leave this plus, then we leave this to differentiate this. Okay? So when you differentiate sec, what will you get? Differentiate sec, you get sec tan. Sec t tan t. Alright. So therefore, this is the derivative part. Then we now come. Oh, I don't think these few steps should be a problem for you. Alright? Don't let it be a problem for you to hate this method. So we have this and this. Do the substitution to this. Okay? So so that is the S dt part minus S. No, we have the S already. So let me write see multiplying the S, and the S is which is equal to sine t. How we can see here sine t in case you don't see. And when you don't see the sign, something must kill a man. Very good. All we can see that something will cancel something. If it's not like that, then something is wrong somewhere. This is the same as this. Okay? Set time, C of S, C of S. Come on. In fact, always, when you get to this part, always, if only you truly did it well. Something here will cancel something here so that you create the one in terms of C prime to the other side. So you make this the subject. simplify before you go and do the integration so that you will not cry on your way. You know that this is the same math. And you know this is cos t. 1/sec is the same as. So we have c prime of x is equal to sin t cos t. So we integrate both sides as respect to x, integrate both sides as respect to x. So we get c of x to be equal to integral of sin t cos t dx. In fact, you can't do away with calculus 1 and calculus 2 as far as ODE, that is ordinary differential equation, is concerned. And since you can't do away with this, you can see what we have here. We need to integrate it. And what is that? I'm sure somebody there is saying integration by part. Please, that is not integration by part. The fact that you see function, two functions being multiplied is integration by part. Alright. We will come back to this. Please, I would like to finish this. So, the T. Oh, I'm making okay. Oh, I'm making a mistake. Wow. This is supposed to be in terms of T. Sorry. But the process is the same thing, T. Because how can you take the derivative with respect to T and be saying that C of x is C prime of x? No, it can't be. T. Please make that part I claim T, alright? So that is T. Thank you for your understanding. Now you know that straightforward. Sin 2 t is equal to 2 sin t cos t. Therefore, sin 2t 2 over. Now, this is not the first or the last time doing this on this channel, alright? If you are calculus 1 and 2 is not good, please go back and check on our YouTube, alright? Go back to YouTube, search Math Expert, check the playlist. We have calculus 1 video tutorial there, we have calculus 2 video tutorial there. You will see that I did similar thing to this. So, for you to integrate this, the same as integrating this. So here, half will come out integral of sin 2t. And when you integrate this, integration, the constant will divide. Integrate this, you get cos 2t. So you end up by getting cos 2t over 4. Very good. So that is that for that. So C of t is therefore then we come back and do the substitution. So you know that S of P is going to be C of T is cos 2T over 4 very good times sec T. And we have already established the homogeneous part to be C sec T. Alright, so that is that for that. Therefore, today if I'm not working well for you, don't worry. I have had a small injury in my leg. That is why I'm not all that fit today. But I hope you have been blessed by it. We have a long way to go in bringing you all these video tutorials. So you need to sometimes sacrifice. Therefore, the general solution becomes y of h plus y of p. And therefore, the y of h is c sec t plus the y of p, and that is, where is the y of p? Okay, that is cos 2t 1 over 4 multiplying sec t. Very good. So this in terms of t, in terms of t. So this is the general solution for our first order linear differential equation. I hope it's not difficult. Make sure that you grab the concept well to be able to come out with it. In fact, I have solved 2 questions out of the 6, but I'm sure that I can stop the rest for you. Or one more, don't worry. I'll be back with one more. Oh, I have forgotten that we were given the initial value. So here, you put t to be equal to 0, s to be equal to 2. Alright? And with that, you are going to get, you put, sorry, there is another mistake also. No, you. The general solution, not that mistake, the general solution supposed to be like this. Very good, supposed to be like this. So, here, supposed to be like this. That's going to be the general solution. Alright. So you put s of t to be equal to 2, then t to be equal to 0. And that is going to help you to find c. And after getting the c, you come back and write it. You know this already. Very good. Thank you. Now, let's continue. Let's look at our third question. Alright, so I took the 6th part to be our last question. From the 3 questions I said I will solve with you. Alright, so you know all this process already. Very good. And this is where we are. That is the, sorry. Okay, so this is the particular solution. Very good. So we continue to, you know that we can simplify this. Y of P is C of S times 1 over sec S. This is the same as cos S. Alright. And for that case, same as C cos X. So we now go and take the derivative of this. You know the process already. Alright. Oh, I will need that part. Okay, this part. Alright, so we pick y of b product rule. Differentiate cos, you get negative sign, so here will be minus. If you don't make it minus, it will affect you when you're doing the substitution. So by substitution, the divide yes here is this. Plus the y is this. Then the y multiplied times x to be equal to sin 2x. Something must kill a man. Oh, you can see that this is not the same as this, but it's still the same thing. Watch. So that I can cancel it for you. Tan is the same as sine over cos. So this cancel this. So now you agree that this is the same as this. So this cancel this. Because it will be left only sine. To be cos times sine over cos, and that will cancel. Alright. Now you can see that today I'm not well that fit to write. I got a day in my legs 3 days ago. But we need a lot to do. We have to do a lot. We have a long way to go under this course. So I need to sacrifice and continue with it. Alright, so just focus on the board and not my legs. Alright, so we have this to be equal to that. And before you integrate, be careful. Since, okay, you know what? C prime of x is equal to sine 2x over cos x. So C prime of x, you know that this is the same as 2 sine x cos x from double angle and the trigonometry. This cancels this. So when you integrate as respect to x, you get this to be equal to 2 cos. But when you integrate sine, you get negative cos. So negative cos x. So finally, we get that to be that. Therefore, y of p will be equal to 2 cos negative 2 cos s. But there is a cos s here. There's a cos s here, so cos squared s. So that is the particular solution. So for us to get the general solution, that is going to be, we know that the y of h is c cos x. Therefore, finally, we are going to get y of h plus y of p, which is going to make here negative 2. Alright, so that's going to be your final answer for the general solution. Thank you and see you in the next video. Alright, so in the next video we are going to look at the method 2. That is another way in finding the general solution for the first order differential equation, the method 2. And don't forget that this method is called, the method 1 is called undetermined coefficients. Undetermined coefficient, that is when it is in a homogeneous part and you are to find the when it's in non-homogeneous parts and you have to find the general solution. Alright. The method 2 is using the integrating factor. Using the integrating factor to find the general solution. So we'll be looking at it in the next video.